All right, so when we left off, we had finished this example 5 and found tangent t and cosecant t. So let's work on example 6 here, and let's use an appropriate Pythagorean identity to find tangent of t. So go ahead and give number 6 a try. So the Pythagorean identity that has tangent in it is the one that says tangent squared plus 1 is equal to secant squared. Well, if secant of t is the square root of 11 over 3, then secant squared is going to be 11 over 9. So we can say the tangent squared of t plus 1 is equal to 11 over 9. And we can subtract 1 from both sides. And then we get that the tangent squared of t is equal to 2 over 9. And then we can take the square root of both sides. And when we do that, we get that the tangent of t is the square root of 3 over 2. Now, the other thing that we also have to pay attention to here is that we are told that our t is in between 3 pi over 2 and 2 pi. That means that the angle that we're looking for, oh, that's a horrible unit circle, y'all. So we have 0, pi over 2, pi, 3 pi over 2, and this is also considered 2 pi. So the angle that we're looking for is going to be somewhere here in fourth quadrant. Okay? And in the fourth quadrant, we know that the only function that is positive is cosine and secant, okay? Because one thing that we also need to remember is that when we take the square root of a number, we take the square root of 2 over 9, it actually gives us plus or minus square root of 3 over 2. And we need to determine which one is it. Well, if cosine is the only positive function in fourth quadrant, this means that ultimately our answer to the tangent of t must be negative root 3 over 2. All right. So take a minute and let me know if you have any questions about 5 or 6. All right. So now let's talk about what's called the periodicity of our trig functions. And what the periodicity means is how often does the pattern repeat? And I'm trying to see if I have, no, I don't. Okay. So if you take a look at the student notes and go to the very last page, you will see graphs of sine and cosine and then also of tangent. And what you're going to notice is that sine repeats every 2 pi. So does cosine, so does cosecant and secant. Tangent and cotangent repeat every pi. So as you're looking at the graph, you can see that these repeat. So that's why sine and cosine have a period of 2 pi. along with their reciprocals, cosecant and secant, and then tangent and cotangent have a period of pi. Okay? So we can use this knowledge and our unit circle to evaluate these expressions if it's possible. It might be, it might not be. Okay? So this is where we need to pull out our unit circle or have it memorized. Okay? And you will need to have the unit circle memorized. All right? And if you recall, I mentioned that really you only have to memorize like the first quadrant and then remember all students take calculus. All right. So this is 1, 0. This is 0, 1. -1, 0. 0, -1. All right. And then here, okay, this is going to be the pi over 6. So cosine, or the x, is √3/2. And sine, the y, is 1/2. This one is going to be the pi over 4, and this is √2/2, √2/2. And this one is going to be the pi over 3, which is going to be 1/2 and √3/2. So now, when you consider -7 pi over 4, well, -7 pi over 4, okay? We're going in the negative direction. And we are going all the way around to here. So the cosine then is, what's the cosine of -7 pi over 4? Cosine is √2/2. The tangent of -pi over 2. Well, first of all, -pi over 2, we're going in the negative direction, okay? And we're stopping here. This is -pi over 2. So what is the tangent of this? So the tangent, because this is the point for this is 0, -1, the tangent is undefined. All right, so take a minute and do 9 through 12, and I'll be back with you in a moment. All right, 17 pi over 6. Well, I think my circles are going to get smaller and smaller. Okay, 17 pi over 6. We have gone around the unit circle one full time, and we've ended up over here. Okay, so we've gone around and around. And when we think about what that is, okay, that is like in here, we have pi over 6 left to get to the next x-axis. And because of that, this our reference angle for this is going to be pi over 6 in the second quadrant. And in the second quadrant, sine is positive. And so pi over 6, or the sine of 17 pi over 6, is 1/2. Now, the secant of 17 pi over 6, we can actually use this same little mini circle that I drew here. Secant is going to be the reciprocal of cosine. Well, the cosine of 17 pi over 6, okay, the cosine of 17 pi over 6 is going to be negative root 3 over 2. So that means that secant is going to be negative 2 over root 3, which we don't write it like that. We have to rationalize our denominators. So we have to multiply by root 3 over 3 to give us negative 2 root 3 over 3. Okay. The cotangent of 7 pi over 3. Well, 7 pi over 3, that is going to be 1 pi over 3 past 1 full rotation. So the cotangent here is going to be cosine over sine, which is root 3 over 2 over 1/2, or just root 3. And then cosecant of 3 pi. Well, 3 pi is going to be here. We go around once and stop. And cosecant is the reciprocal of sine. So we need to consider what's the sine of 3 pi. And the sine of 3 pi is 0, which means that the cosecant is going to be undefined. All right. Last thing that we're going to go over here, y'all, is even and odd functions. So if a function is even, then when you put in negative x, it just gives you the function right back out. And if it's odd and you put in negative x, it gives you the negative of that function. All right? So the cosine of negative t is equal to the cosine of t. So cosine is even, but sine is odd. So when we consider that sine is odd and cosine is even, that means that tangent is also odd. So looking at these here, I'm only going to do the first one because we're not going to spend a lot of time on even and odd. It is helpful, but we'll get into it, okay? So the tangent of t plus pi, because tangent has a period of pi, that means that this is just the same as the tangent of pi. And because cosine has a period of 2 pi, oh, I'm sorry, not pi, t. Don't mind me, y'all. Cosine has a period of 2 pi. This is the same as just cosine of t. And because tangent is sine over cosine, when we multiply, we just get sine of t.